Alright, hello everyone. Now we move to our second part of chapter 2. So we'll go deeper on the physics of the gases change. So first of all, what do you know about diffusion? Diffusion will be this process where a solute moves to moves through this barrier to another area. So from high concentration to the low concentration. So that's how our oxygen is released. That's how we get our oxygen, and that's how we deplete our CO2. So diffusion will be better if there is a large surface area. A more concentration gradient means that there's a big difference between the high and the low. Okay, and there must be a thin surface across gases, a diffusal. So mean that in between the two barriers, it must be a bit thinner. Okay, so as you can see here, a small cube will have much more surface area compared to the volume, so it can absorb a lot. There is a lot of surface for absorption. But for the second one, you have a large cube. A lot of the volume are locked within this small surface area, so the absorption is not really that good. So TSA will be 3 instead of 6. Okay, other factors will be a good blood supply. So you need a blood supply which is good so that you can carry the blood all the way to tissues and to maintain a C gradient from high to low. And temperature, you need to have a warm condition instead of a cold condition. So diffusion will be faster in warm conditions because why? Because molecules have more energy. I mean that is much faster. Okay, so here's Fick's law. So the rate of diffusion will be better if we have area of diffusion surface multiplied by difference in concentration over thickness. Meaning that the more area, the faster diffusion is. The more concentration, the faster diffusion is. And if the area becomes thick, the surface diffusion becomes thick, diffusion will be slowed. So you need to have an area which is large, which has a large difference in concentration, and also a thin surface. It means that water, it is a small molecule. It has higher concentration inside of the body and the outside. It will continually diffuse out of the animal and evaporate away. So it causes the diffusion surface to be moist. For unicellular organisms, you have this very small size, okay, very small volume. It doesn't need any organs because gases can directly diffuse through the cell membrane. Smaller size equals smaller surface area, meaning that they have more surface area compared to volume. Unicellular organism would have a large TSA over V ratio, meaning that it would carry oxygen very fast, very quickly. All parts of the organism will be supplied by oxygen because the path between the outside and the inside will be short. So the gas doesn't have to cross a lot of distance. So what about multicellular organisms? They are much more bigger than unicellular. It means that diffusion of gases will be much more difficult. So you have these animals which are small and large but very thin. So for them they are okay because they can still get enough oxygen because they are thin enough. But for others, you need specialized exchange surface like gills or lungs. So you also need an internal surface exchange to prevent the loss of H2O because because if an animal is continuously exposing its exchange surface, it will go dry. So plants do not have any lungs, but air diffuses through this holes called somata. Somata opening is controlled by the gut cells. When the gut cells open, the air can come in, mean that CO2 can get in, O2 can get out. So opening and closing is dependent on the time of day, 6 a.m., 9 a.m., 12 a.m., 12 p.m. Okay, until 6 p.m. So in those times, the plant is still doing photosynthesis, so they're open. So at night, there is no photosynthesis, so they will just close. Insects have these small holes called the tracheoles connected to spiracles. So spiracles are these really small holes near the body. Okay, is alongside the body you have a lot of holes where they will absorb the air. And spiracles will be connected to tracheae, which will be connected to the air sacs. So they have a liquid in the body called hemolymph. So for insects, oxygen is dumped directly into this liquid. So meaning that they don't have any blood vessels. Air is just dumped into that liquid. Okay, so the movement of the body, ventilation might help with diffusion. So meaning that if you spray them with something like an aerosol, okay, a bug spray, they can easily die because the gas absorbs readily into the body very quickly, very rapidly. Okay. The spiracles can be closed by valves and may be surrounded by tiny hairs. So they're kind of like nostril hairs. So they just sweep out the dust, sweep out the whatever that is getting in, maybe water vapor, maybe dirt. Okay. And also it can cover the hole so that it will not be dry. So what are fishes? So the way that fishes work is that they have gills. So they would swim forwards and the water will move from the mouth all the way to the back of the body. So it actually creates this directional movement of water carrying oxygen through the gills. Okay? So meaning that as water carrying oxygen goes through the gills can absorb oxygen. Okay, so the thing is, if you want to compare us humans and fish, okay, so our blood vessels go from the heart all the way to the body and get to the heart again. But for fishes, um, the way that the blood vessels run is that the blood vessels run in the opposite direction of the water. So meaning that when the water moves into the mouth, the blood is coming from the other direction. So due to that, we can call it the counter current flow. The oxygen, I mean, the oxygen-less blood, it will move from backwards to forwards, and it will meet the the oxygen-rich water, and it will be enriched with oxygen. Okay, so this is actually very special because they can actually get water's oxygen 3 times faster than how a human can. What about sharks? Sharks have low blood pressure. Most must swim continuously. If they stop swimming, they'll just die because they need the muscle contractions to move the blood. So if you look at the heart, their heart has only 2 chambers, meaning that the pump will be weak. And also, in terms of red blood cells, they have fewer but larger red blood cells. Okay, so let's say that if we have a fish whose blood flow is um, parallel to the water, meaning that the water moves from the mouth all the way to the back, front to back. What if the blood also moves from front to back? Okay, you must remember that to actually get oxygen from the substrate, water or air, you must make sure that there is a gradient. Okay, in your blood, it must be low oxygen. In the air or water must have high oxygen. So from high to low, high to low. If the water and the blood is moving at the same direction, mean that in the beginning you have 0 oxygen in blood, 100 oxygen in water, and then you go 20 80, 70 30, 40 60. What happens when you have 50 50? At this point there is an equilibrium. It means you will no longer have any diffusion. Diffusion will totally stop. At 50 50, it is saturated. So in real life this doesn't exist. Okay. So what exists will be the counter current flow. So um, the thing about blood is that blood in fish is that even though the water is absorbed until it is like 2%, 1% or 5% oxygen, very very low, it will still be absorbed by the blood of the fish. Why? Because the blood coming from the fishes into the gills are always 0 oxygen. If you want to compare between 0 and any number, 0 is the lowest. So meaning that the oxygen will always go into the blood of the fish. You will always be saturated. What about humans? Humans would use the lungs, and within the lungs you have alveoli. So alveoli itself, it is a very small cluster of organs. It is used to maximize the surface area for diffusion. And to minimize the distance of diffusion, alveoli are just one cell thick, covered by numerous blood vessels. And also, in your throat, in your nose, you have a lot of these cilia and also a lot of mucus. All of these are to warm the air and also to clean the trachea, clean the air before getting in. So what about breathing? Breathing in and out is controlled by your medulla in the brain. Medulla is this area in the part of the brain, in the back of the brain, that will be subconsciously controlling your breathing center. Okay, so you don't have to think to breathe; it is automatic. So intercostal muscles and the diaphragm receive impulse from the respiratory center. Mean that that part of the brain will be telling your ribs and also your diaphragm what to do. Okay, it's like pumping, pump, release. Okay, so your lungs, when it is filled by air, it will stretch. So it will turn on the receptor. It will cause the respiratory center to accordingly release or pump the lungs. Okay. Okay. So breathing rate. So how fast can you breathe for each breath? How many breaths can you do for each second? Okay, that's what's called the breathing rate. So usually at rest we require about 6.0 decimeter cube per minute, or and about 0.35 would enter your alveoli each breath. So there is some air that could not be removed from your lungs. It is called the residual volume. So no matter how hard you breathe out, the RV will still be there. Okay. So the amount of air that you can breathe in and out is called the tidal volume. So usually for tidal volume, it's like a tide, in and out, in and out. Okay. And how fast can you breathe? It is called your breathing rate. Okay. And how much volume of air that you can breathe per minute? It is called the ventilation rate. Tidal volume multiplied by breathing rate. Vital capacity will be the maximum volume of air that can be breathed in and out again. So vital capacity, how do you measure? You look at the picture there. It is called spirometry test. So you put a clip on your nose and then you take a deep breath, the deepest breath that you can, and then you can blow the hardest as you can. Usually, if you have a normal volume of lungs, you would have like around 6.0 dmt per minute. If you have asthma, it might be lower. If you have emphysema, it might be lower. Okay, so chronic bronchitis, if you look at the name, chronic means long term. Bronchitis means that your bronchus would have inflammation. So if you have bronchus inflammation, bronchus will be this tube that connects between your trachea and also your lungs. If this area is always inflamed, you will have mucus, you will have itchiness. You would be blocking your bronchus with a lot of this mucus. Mean that for air to get in is very, very hard. Okay, so what happens that because of lack of air, you'll be cyanotic. Cyanotic, cyan means blue. You'll be a little bit bluish. You have a lot more hemoglobin than normal, and you have peripheral edema. I mean that a lot of the liquids would leak out from your blood all the way into your surrounding tissue, and you would have wheezing. So when you wheeze, mean that there is something that is blocking or within your breathing tubes, either bronchus, your trachea, bronchiole. If you want to compare, chronic bronchitis is something that you can actually stop from progressing. If you stop smoking, you will not have any chronic bronchitis, or maybe you stop breathing positive gas, because usually chronic bronchitis will be happening due to something irritating your bronchus. If you want to compare with emphysema, emphysema will be the reduction of the lung volume. So it means that your lung is now a smaller balloon compared to the original shape, meaning that you hold up less air your capacity for oxygen is less, and you cannot breathe very deep. You will have shallow breaths. It's like being hugged by a really fat wrestler, and then you try to breathe through that. Okay, so usually people who have emphysema, they'll be older, they'll be thinner, they have dyspnea. Pnea means sleep. Dyspnea means that you have this a disruption in your sleep. It's very hard to sleep. Okay, and also you have a quiet chest, meaning that when the doctor uses this uh, okay, when doctor uses the stethoscope to listen to your heart, to listen to your chest, there is nothing. There's no sounds. Okay, so emphysema, the telltale signs of emphysema will be by X-ray. By X-ray, you can actually see that the lungs, the actual lung volume will be much less compared to normal, because the area where the X-ray can go through is usually dark, but the area that has emphysema will be a little bit whitish because your lungs has actually decreased. Okay, so breathing in, intercostal muscles will contract. If you want to compare with breathing out, it will be relaxing. For your ribs and sternum, you'll be up and out. Okay, you can just feel it by yourself. Your ribs and sternum will be moving up and out. So if you breathe out, you'll be moving down and in. Your thorax, you'll be wider when you are breathing in compared to breathing out, and your diaphragm will be contracting, meaning that it will be flattening so that more air can come in. But when you breathe out, you'll be relaxing. Okay, so the diaphragm will move down and flatten to allow air to come in, but when you breathe out, you'll be inflating and so that it will be moving. Diaphragm will be increasing top to bottom, meaning that when you see somebody breathing, you can see that their shoulders will be moving up and down, meaning that the thorax or the top of your body will be much more taller or higher or bigger. Okay, but if you breathe out, the depth of the thorax would increases top to bottom. I mean, it should be decreases, not increases. Okay, so as the lungs fill with air, the stretch receptors will send an impulse to the respiratory part of the respiration center to end breathing in. So you cannot actually breathe as much as you can until you explode like a balloon. Actually, before that happens, the stretch receptors would tell the brain to stop breathing and start breathing out. Okay, so as you can see, when you breathe in, your lungs, they are like balloons. They will just expand and inflate. So any other parts will be kind of loosening up. They will be kind of stretching. They'll be flattening so that more air can get into your lungs. Because your lungs is like a balloon, and then around it you have a cage called your rib cage. So your rib cage is not really static because there is part of your rib cage which are floating ribs. Okay, so you have seen this curve before. It is the curve of oxygens that is within your red blood cell versus your tissue. Okay, so if you look at the y-axis, it is what you call the saturation of oxygen. Saturation of oxygen will be how much oxygen that is in the hemoglobin. Oxygen in blood will be the PO2. Okay, so how many are in, how many are out. Okay, so hemoglobin and oxygen act like little parents, act a little like parents and children. When all are living at home, the parents doesn't want any of the oxygen to leave. But once one has flown the nest or dissociated from hemoglobin, then it is easier for the red blood cell to release the other oxygens. So meaning that the more that the oxygen are released from your red blood cell, the easier for the red blood cell to release the other oxygen molecules. So what shift the graph? Um, for the graph to shift, means that your body actually needs a lot of oxygen. What makes you need a lot of oxygen? Maybe you are feeling hot. Maybe you are doing exercise. Maybe you have a lot of acid in your blood. Maybe you have much more 2-3 dpg. Okay, all of this will cause the hemoglobin to release more oxygen. But conversely, if you're in a cold area, if you are having alkaline blood, and if you are um, in a resting position, usually you do not need a lot of oxygen. The oxygen dissociation curve will be all the way to the left. Other than that, carbon monoxide can also sabotage your red blood cell, kind of like denying your red blood cell from oxygen, meaning that what happens that it will not be releasing oxygen to the tissues. Okay, so what about the dissociation curve? If you can see, if you remember cadet. Cadet face right. C means CO2. A, acidity. D is diphosphoglyceride, 2,3-DPG. Okay, and E will be exercise, and T is temperature. So cadet face right. So face right means that the oxygen balance will be pushed more towards the blood, mean that the red blood cell will release oxygen instead of just keeping it for itself. Mean that it will be much more, it's like somebody who likes to donate. Okay, just donate. So you also have these chemoreceptors. They are receptors within your medulla and system blood vessels that they are sensitive to changes in CO2 levels in blood. If the level is too high, the pH will become acidic. It will drop. Enzyme action will be affected. So meaning that it will tell the brain to breathe more, because breathing also can neutralize the CO2 and also the acid within the blood. Okay, so CO2 effect. The CO2 can affect the curve in two ways. First of all will be the pH. Second will be the carbonyl compounds. So both of these will actually cause your red blood cell to give even more oxygen to the blood. I mean to the tissues, from the blood to the tissues. Okay, Boy effect, as we have learned in the previous lecture, it is when you have a lot of CO2 because you do a lot of activities, and this CO2 will cause your blood to become acidic. And when your blood becomes acidic, you will you will release more oxygen. Yes. So, but what about 2,3-DPG? This is a very special organophosphate. It's created in erythrocyte during glycolysis. So when this is released in your blood, it causes the oxygen to be absorbed more. It is something like an adaptive mechanism. So you have a certain special conditions where this 2,3-DPG will be created, like when you have low oxygen, hypoxemia, when you have chronic lung disease, you have anemia, congestive heart failure, among others. Okay, so 2-DPG is something that you release either when you're sick or when you are in childhood, because usually kids they don't have enough red blood cells, but they need a lot of oxygen. So you have a lot of 2-3-DPGs. Okay, what about temperature effect? More temperature, you will go to the right. Less temperature will go to the left. Why is it? Because the hotter it is, the weaker the bond between O2 and hemoglobin. Mean that it will be really easy for the hemoglobin to release oxygen. Mean that you have more oxygen being released. So carbon monoxide. Carbon monoxide is this competitive inhibitor for your red blood cell. So when your hemoglobin binds to carbon monoxide, it will actually ignore oxygen at all cases. Meaning that even though you have very low carbon monoxide, maybe in your car, maybe when you're burning some garbage, okay, if you have any gas leaks, you will just deny your body from any oxygen. So the scary thing is CO or carbon monoxide, they do not have any smells. Okay, you can just collapse. You can just collapse because it doesn't it doesn't tell you whenever it's there. So it is a very popular suicide method for a lot of people. They would just connect pipe from the exhaust into the car, and then they would just drift into sleep. Okay, as you can see here, hemoglobin usually binds with O2 to carry the O2 to the tissues. But in this case, um, your red blood cells, okay, it will get CO or carbon monoxide, it will ignore oxygen, and also it will ignore CO2, meaning that the acidity of your blood increases because there is nothing absorbing them. Because red blood cell is firmly gripped by CO. So no O2 coming in, no CO2 coming out. You get no oxygen, and then you get more acidity. Acidity causes your organs to fail. Okay, and then no oxygen will also cause your organs to fail. So your heart and your muscle will be KO. As you can see here, the telltale signs of carbon monoxide poisoning will be cyanosis, meaning that your part of your body becomes blue or bluish. So even though you are surrounded by a lot of oxygen around you, but you have enough CO to actually stop your body from getting any oxygen, you can actually die of hypoxia, in that you can actually die of low oxygen. Okay, that's all for today. Thank you.